Today on Macaulay Math, we're talking the sum and difference formulas. Intro. Okay, good day. I'm Professor Macaulay. This is Math 150 Pre-Calculus, Lesson 27 on the sum and difference formulas. Our goals for today. We're going to use the sum and difference formulas to evaluate trigonometric functions. We're going to use the sum and difference formulas to verify identities and solve trigonometric equations. This lesson adds the sum and difference formulas to the list of simple trigonometric identities. The sum and difference formulas are used to expand the number of angles that can be evaluated using the unit circle, a skill that was very important before the advent of calculators. Now it can be used as an opportunity to revisit skills already learned during this unit, including evaluating sine, cosine, and tangent along the unit circle and verifying trigonometric identities. Let's get started.
Okay, so here are our sum and difference formulas. And I'm not going to go through all of these, but basically you can see that when they say sine of u plus v, you have the sine of u cosine of v plus the cosine of u sine of v. So whatever these two numbers are, u and v, you plug them into those values. And each trigonometric function has its own unique method that goes with it. And as you use them, you'll become more familiar with each of these sum and difference formulas for each of the different trig functions. Okay, I still have the unit circle here for you to refer to, but here is our first example. And the first example says, find the sine, cosine, and tangent of 165 degrees, given that 165 degrees is equal to 135 degrees plus 30 degrees. Now, as I said in the opening intro, the whole purpose of the sum and difference formulas when they were first invented was to expand the number of angles that you could evaluate using the unit circle, especially when there weren't calculators. So even though we have calculators now, this is a good exercise in algebra. And we see very clearly that 165 degrees is not on the unit circle, but both 135 degrees and 30 degrees are on the unit circle. So what I'm trying to do here is I'm trying to find the sine of 165 degrees, but I'm going to break that down into the sine of that sum, 135 degrees plus 30 degrees. And so, since this is an addition, if I go back up to my sum and difference formulas, since I have a sum, it's the sine of that first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. And so this thing breaks down to the sine of 135 degrees times the cosine of 30 degrees plus the sine of 30 degrees times the cosine of 135 degrees. And so since we all know our unit circle very well, we can calculate those individually. The sine of 135 degrees is square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2 plus the sine of 30 degrees as a half, and the cosine of 135 degrees is negative square root of 2 over 2. And so we're just going to simplify this. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4, and this is going to end up being a negative because I have a positive times a negative, so I'll have a minus there. 1 times square root of 2 is square root of 2. 2 times 2 is still 4. And then I can combine that into a final answer of square root of 6 minus square root of 2 all over 4. And there's no common factor, so that is my final answer for that particular problem. Now, they do also ask us to find the cosine of that 165 degrees. And we break it down the same way. Cosine of 135 degrees plus 30 degrees. Now, the cosine formula is a little bit different. The cosine formula of a sum is going to be the cosine of u times the cosine of v minus the sine of u times the sine of v. And so we can plug those values in. So I have the cosine of 135 times the cosine of 30, both degrees, minus the sine of 135 degrees times the sine of 30 degrees. And we've made all those calculations already. The cosine of 135 degrees is negative square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2. The sine of 135 degrees is square root of 2 over 2. And the sine is 1/2. So I have negative square root of 6 over 4 minus square root of 2 over 4, which gives me negative square root of 6 minus square root of 2 all over 4. And then we have to do the tangent as well. So the tangent of 165 degrees is equal to the tangent of 135 degrees plus 30 degrees. And if we go back up, when we do a sum of tangent, it's the tangent of u plus the tangent of v all over 1 minus the tangent of u times the tangent of v. So let's make those calculations. Now, if you remember, tangent of theta is the sine of theta over the cosine of theta. So I'm going to calculate both the tangent of 135 degrees and the tangent of 30 degrees separately, and then we'll just plug in. So the tangent of 135 degrees will be the sine of 135 over the cosine of 135. And since the sine is square root of 2 over 2 and the cosine is negative square root of 2 over 2, this thing becomes negative 1. The tangent of 30 degrees is equal to the sine of 30 degrees over the cosine of 30 degrees, and that gives us 1/2 over square root of 3 over 2, and my 2's cancel, which will give me 1 over the square root of 3, and if we multiply that by square root of 3 over square root of 3, we get square root of 3 over 3 as our final answer. So the tangent of 135 is negative 1, and the tangent of 30 is square root of 3 over 3. So I can plug those two into the 4 tangents that I have here. So the tangent of 135 is negative 1, plus I get the square root of 3 over 3 for the tangent of 30. That's going to be all over 1 minus negative 1 for this tangent of 135 times square root of 3 over square root of 3. And so let's see if we can simplify a little bit. I'm going to get negative 1 plus square root of 3 over 3. And then I'll have over 1 plus square root of 3 over 3. And unfortunately, because these are not like factors, I have a negative 1 in the numerator and a positive 1 in the denominator. I can't just cancel and make it 1, which kind of stinks. So what I'm going to have to do is I'm going to add fractions in both the numerator and the denominator. And that's going to give me negative 3 over 3 plus square root of 3 over 3. So I'm changing this negative 1 to square root of 3 over 3. And that will be all over 3 over 3. That's this one right here, plus square root of 3 over 3. Then I'm going to add those fractions, which will give me negative 3 plus square root of 3 over 3 all over 3 plus square root of 3 over 3. And these 3's will cancel. And I'll just save myself a little space here. And since those 3's cancel, I'm left with -3 plus square root of 3 on the top. I'm left with 3 plus square root of 3 on the bottom. And I want to get that square root out of the denominator. So what I'll do is I'll multiply by the conjugate of the denominator. So I'll go 3 minus square root of 3 over 3 minus square root of 3. This I'm going to have to FOIL. And when I FOIL that, I'll get -3 times 3 is -9. I'll get plus -3 times negative square root of 3 is positive 3 square root of 3. Positive square root of 3 times positive 3 is another positive 3 square root of 3. And then positive square root of 3 times negative square root of 3 is -3. And that will be all over. In the bottom, I'll have 3 times 3 is 9. And then it will be -3. And when I add all that together, I get -12 plus 6 square root of 3. And then that'll be all over 6. And I can take a 6 out of every term. So my final answer, finally we get to it, will be -2 plus square root of 3 as my final answer. Oh, that one was a lot of work, but we got there. All right, example, find the exact value of the following expression. The cosine of pi over 16 times the cosine of 3 pi over 16 minus the sine of pi over 16 times the sine of 3 pi over 16. Now, 3 pi over 16 is not on the unit circle. But what I see here is that cosine minus sine of the same two angle measures fits this sum or difference formula. So what I can do is I can take these 4 terms and simplify those down into a single term. So let's do that. And we'll rewrite that as the cosine of pi over 16 plus 3 pi over 16. And what that will allow us to do is to add these two. Since they have common denominators, this becomes the cosine of 4 pi over 16. 1 pi plus 3 pi gives me 4 pi. That thing simplifies. The cosine of, I can divide a 4 out of the numerator and the denominator, which will give me pi over 4. This thing is on the unit circle, which would give me square root of 2 over 2. We put a box around that and we are finished. All right, last example. Here we are at verifying the trigonometric identity. And we want to verify this. Clearly, we see a sum for a cosine and a difference for a cosine. So we have these two expressions. So what I'm going to do is I'm actually going to substitute the sum and difference formula. So again, if we look back up here for the sum of a cosine, it's cosine u cosine v minus sine u sine v. And then cosine u minus v is cosine u cosine v plus sine u sine v. So it's very easy to see that when I substitute in, I'm going to get these two terms that cancel out. So actually, it turns out to be pretty easy. The cosine expression, this becomes the cosine of x times the cosine of y. And then it's minus sine x sine of y. And so now I've taken care of just this first part here. And then plus, I'll do the same thing. I'll do the same expansion with the difference here. And we'll have cosine x times the cosine of y. And this time it'll be plus the sine of x sine of y. And we see pretty quickly that these two cancel. Put an equals there. And that'll leave me with cosine x times cosine y plus cosine x cosine y. And since these two things are the same, I have 1 cosine x times cosine y plus another cosine x cosine y leaves me with 2 cosine x cosine y, which is what they're asking us to find. So we have verified that identity. All right, that's all I got for today, folks. So, the Star Wars fun fact of the day: in The Empire Strikes Back, when Leia professes her love for Han Solo, the original script was to have him respond, "I love you too." But Harrison Ford and the director thought that line wasn't BA enough for our favorite scoundrel, so they changed it to, "I love you, I know." And George Lucas agreed. I agree also. I think it's probably one of the coolest things ever said on film. But hey, and what do I know? I'm just a math teacher. Well, that's all I got for today, folks. You have a great day. Goodbye.